Hello, 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 hello. Hello, 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 hello. Mic 被锁住，麦被锁住。嗯，我在叫人，他没有回我，我在叫他。做工，做人做工。Hello. This mic is not mic. Yeah. 嗯，啊，
开始连接话筒，
可以了。
已解锁，请取出话筒。
OK。
已上锁。
对。Testing. All right. Haven't seen you for a week, so let's start from vector field again. When more people come, we can talk about project two. Okay, so let's pick up from where we stopped last time. So last time we introduced an object called vector field. So what's the vector field? So what are vector field? So vector field are function from Rn to Rn, but in our case, we will just consider function from R3 to R3 and a function from R2 to R2. So a function from R to R is what you learn in calculus 1, right? So in vector field, we learn higher dimensional Rn. And today we will learn vector field together with a scalar field. So what's a scalar field? So scalar field, we will fix the codomain to be R. Okay, so for example, function from R3 to R, or function from R2 to R. Okay, so a function from R to R will belongs to both of these terminology. Okay, so how should you think about these vector fields? Fields. So how should you think about vector fields? So for example, for function from R2 to R2, right? Okay, so your codomain is an R2, is a plane, right? Okay, so you should imagine you've got a plane, and then above this plane, what do you have? You attach a vector. Okay, you attach a vector. Okay, you attach a vector like that. How about scalar field? Okay, so for example, from R2 to R, on a field, okay, every point is just attached with a number. Yeah. Okay, so how do you imagine this field? For example, if you go outside A3, right? Is there a field? 有没有草场在 A3 外面 Right. So for example, if you're running around that 你在那个草场上面跑或者走路 okay, what number I can attach to you? I can attach the number of, for example, velocity. 跑得多快，你在那个点上面跑得多快。Okay, so there's a function. Okay, from x y to r. Okay, 在那个点，你的速度是多快？ So at every point, what's the velocity on you? Okay, so what I want to say is this scalar field or scalar function is a very normal object you will consider in real life. Understand or not? Okay. 一起听得懂我讲话吗？重复一下。OK，然后那个 velocity 是一个 vector field or scalar field。scalar，如果是 speed 的话就 scalar 咯。如果有 maybe 有 magnitude direction，可能你可以 attach 一个 vector。OK，then 它就是一个 vector field。OK，OK，so there's a natural way to get a vector field from scalar field. Actually, you see it before. Okay, how to obtain a vector field from a scalar field? What do you think? Actually, you see it already. Can you imagine what we have learned before? So we learned this type of function where in which chapter? The chapter. Yeah, partial derivative, multiple integral, right? So I claim that we have seen vector field before. From scalar field, we can create a vector field. 还记得吗？讲一下，有看过吗？ From this kind of map from R2 to R, we can create a function from R2 to R2. Have you seen any vector in the partial derivative chapter? 还记得吗？ Directional derivative or the gradient. Gradient, right? So if I give you a fxy, okay. So what's the gradient of fxy? Do you remember? 来，伟权，还记得什么是 gradient of? What should you compute here? 找一下。What's the gradient of a function of two variables here? 是丙雄 ，yeah, delta f delta x over delta f over delta y. So this is, did you recognize that this is a function from R2 to R2 or not? Is it from R2 to R2? So you input, what do you input? You input a point. If you input a point, actually this is a point in R2, xy, right? And then you output what? Output a vector. Okay, what's this? How many terms in this vector? Also 2 terms. Okay, so actually you have a natural way to obtain these vector fields. Okay, from a scalar field. So let's quickly do one exercise here. So if the question asks you to find a gradient vector field means what? You want to find the gradient of f here. Okay, so look at this function here, fxy here. So this is a scalar function. So this function is going from R2 to R, right? Because if you substitute the x and y in R, you will get a real number out of this. So to compute this gradient vector field, what do you do? This is what we did in the previous chapter here. Okay, so you do partial differentiate f with respect to x, and then partial differentiate f with respect to y here. Okay, and what do you get? I think if you quickly compute it, you should see 2xy and then x squared minus 3x. Okay, now any question? So we just introduced a new terminology here. We call it a gradient vector. Instead, this is just a gradient vector. Okay. So far, okay or no? Okay. Okay. Let's move on. So we want to call something a conservative vector field. So what's a conservative vector field here? So obviously this is a vector field, but what's so special about this vector field here? This vector field here should be a gradient of a scalar field or a scalar function. Okay. And then we will call that scalar function as a potential function, okay, of the vector field f. So we will write this f as a gradient of f if this capital F here is a conservative vector field. So a remark down there is not all vector fields are conservative. Okay, you can imagine that not all vector fields come from derivative, right? Partial derivative. Okay. So, but this kind of thing frequently happen in physics. Okay, so that's why they consider this. Right. So, for example, if we gave you a vector field which is the gravitational force field here. Then we want to show that F is a conservative vector field with potential function given here. So what should you do here? By definition, to show that F is a conservative vector field, you just need to show that F is equals to delta F for some small f here. Okay, but this small f is already given. So what do you need to do? You just need to verify. Okay, so what do you need to compute here? What do you think? Yeah, take gradient of what? Which f? Who f here? Huh? Sorry. Little f, okay, so you take gradient of little f so that you check whether it is a little f or not. Okay, the vector field f. Okay, so can you try now? I give you 2 minutes. Note that just now I just only give you an example of 2 variables. Here is 3 variables. So a principle around this calculus 2 is whatever you do to 2 variables, you can do to 3 variables. Okay, I want to check solution. What is delta of little f here? So you just partial differentiate your function 3 times with respect to different variable. And so this involve differentiating inverse of a square root. Okay, and inside that square root, you have multiple variable, and you should do chain rule. Okay, you should do chain rule on these terms. Can you see that these partial derivative is symmetric or not? Can you see? They are symmetric, right? Okay. So Actually, you just need to compute once and then the other should follow the same calculation. So one term you get is negative half of cx squared over x squared plus y squared plus z squared to the power 2, and so on. Okay, so if you collect them together, you can see that they have the same factor. What's the same factor here? Let me see. Is there a 1/2 there? So there's an extra 2 here. So the 1/2 will cancel with the 2 coming out from this. Oh, sorry. There's no square there. So that's a proper 2. So if you do a chain rule, then you get 2x from x squared here. So the 2 cancel. So you're left with a c and minus sign. So all of them have the same constant. You can pull it up. So two terminology here you need to be careful about. One of it is a potential function, which is a scalar function or scalar field. And after you take the gradient, then the vector field you get is a conservative vector field. Okay. So in general, what could the question be? Maybe the question will ask you, find, show that f is a conservative vector field without giving you a potential function here. Okay, without giving you a potential function. Then you need to look for it yourself. Then can you imagine what you should do there? Can you imagine what you should do there? You get a bunch of partial differential equation. Yeah, I believe in the ODE you learn how to find solution to your ordinary differential equation. Right? So you should do similar thing there. So you integrate the partial derivative. I think later we'll see some example like that. Then I will notify you again. All right, so next thing is about line integral. So the line integral. So let's talk about idea of line integral first. Okay, so the idea of line integral is easy. Okay, so it's generalizing what you did in calculus 1. So what you did in calculus 1 was your graph will live on a plane, okay, from x to xy. So it's a kind of flat line integral here. So you compute the area under this line here. But for our line is different. Our line permits through R3. Okay, so my line will move in R3. Okay, move in R3. Maybe it's not straight anymore also. Okay, it's not straight anymore. So maybe go curve like that. Okay, so how to, in this case, how to compute the area under this integral here? Okay, so we need to think about that. Okay, so how to compute this kind of thing? How do you imagine this? Any object you can relate to this kind of shape, area under this curve line. Can you imagine or not? Area under curve line. That one. Curve line. Area under the curve line. Imagine. Yeah. Okay. So how do you do this integral here? How do you do this integral? Well, in calculus 1 case, if you describe this as fx, then the integral is just integral fx dx here. Okay, but for the new case, how to describe this curvy line in 3D? How to describe it? How to describe it? Huh? Sorry? fx? fxy? So, well, you can tell me the point, the height, okay, of the point in where? In R2, right? And then you integrate over what? Only over this region here. Okay, this region let's call it C, this line here. Integrate over C. And then what should we put here? Dx dy? Okay, but in fact, we will do it as D capital S here. But we have seen D capital S before, right? So you have seen D capital X before, right? So remember last time we want to compute the length of the curve, right? So we use this dx to denote how we compute the line that is not straight. Fair enough. So how do we make it straight? Do you still remember? How do we like measure curve line in space last time? Remember the story about the ruler of the square root of dx squared dy squared last time? So let's jump to the formula first. So what this dx here? So this dx here, you could parametrize your curve, okay, using t. But there's a factor of this. Last time I told you, right? The Pythagoras theorem factor here. Okay, the curve line. Okay, so this is the new line integral here. So what's the difference? So what's the difference between the calculus one integral? What's the difference here? Okay, so the difference here is this C. Okay, this C is curved in space. So you need to make it straight. You see? The right hand side here is what you did in calculus one. Okay, the left hand side is what you learned now. Okay, so you try to make it into the one that you can compute. Okay, so what do you think about this A and B here? What do you think? What should this A and B be? Endpoint, the starting point and endpoint. Okay, this A and B refer to the range of the variable you take. So what's this dt here? This t is to parametrize your curve line. Okay, so you see, we involve the parametric curve into this integral now. Okay, so we in this last chapter, we will put everything together. Okay. So without this f, right, you are just compute the length, but this f will give height to the length. Okay, so that's why we are computing the area under that curve. Okay, no? Area under the curve. Okay, so previously you don't have this, right? This is just one. Then you are just computing the length of that curve. But now we add in the height. So the function, this two variable function here give height to the curve line. Okay, so once you give, you see, if you look at this curtain at the bottom, you can see the curve. But if you give the height, you will get the whole curtain. So this is what we're trying to integrate over. Yeah. Any question? All right. So let's try some question. Okay, so if the function is greater or equal to 0, then this is the curtain we talked about just now. Or sometimes they call it fence. All right, so let's do some computation here. So try and evaluate this function, okay, with respect. Here, this curve C is described by a circle equation, but you don't take the full interval from 0 to 2 pi. Instead, you just take until pi, so half of it. And then ask you to show that if we integrate it in a different way, so we parameterize in a different way, we also give the same value. Okay, so let's try how to do this. Well, so first thing first, you need to determine what's your domain first. Okay, so what's your domain? What's your domain C? So how to describe your domain C here? So it is a set of xy R2 such that what? Okay, such that x equals to cos t, y equal to sine t, and then t is in between 0 and pi. So so this picture here, let me ask you a question here. So this picture is a domain or a graph of 2 plus x squared plus s squared times y? What do you think? Is this a domain picture or this is a graph that you try to integrate over? This is just a domain, right? Okay, so you should imagine that all these points here, you should attach a number called 2 plus x squared y. Okay, so you have a height here. Okay, so your curtain is like living in the 3 dimension. Okay. Mm. Maybe you can go back and try and sketch this curtain out. Okay. Yeah. Okay. Right. So what's the formula here? Integrate over c of 2 plus x squared y dx equals to what? Okay, equals to what? So what's the formula? So shall we? So I think it's better to screenshot the formula first, and then we can compare it. Right. So we are using parametrization to compute this integral here. So let me ask again, why we care about this parametrization? Let me ask Chung Xiang, why we need to parameterize first before we computing this line integral? Hmm? What do you think? Okay. So why should we parameterize this C first before computing this line integral? 第一个范围 region，可是我知道啊，我知道范围是这个circle啊，0 to pi。嗯然后well, I mean, you see, this function is a two variable function, right? Okay, so but we integrate over one variable only. So how to go from two variable to one variable here? Ah, ah, that's good. Okay, I wouldn't say that there's a change of variable because usually when we do change of variable, it's between one variable and one variable, two variable and two variable. But now we are trying to describe a two variable line in one variable, and this is doable. 它的问题是我们可以做到这点，为什么？Because this is just a line。哇，你的 line 是在 two dimensional、three dimensional、four dimensional，我都可以只用一个 variable 来形容它。OK，这个是重点。OK，this is the main point. And then once you make this two variable line into one variable, then this is just a calculus one thing. OK, no. Does it make sense? OK 吗？听得懂吗？OK, so let's do this parametrization here. So if we pick this parameterization, what do we get? So we try to integrate from 0 to pi of 2 plus, what is s squared? What's the new s squared here? We make it in terms of t, and then y also in terms of t. And then what's the dx here? Becomes, you have a factor of square root of x prime t. So in this case, you get minus sine t squared plus, and then y prime t you get cos t squared of d dt. Okay. So in principle, this dx and c is live in R2. But once we parameterize it using one variable, then we integrate over one variable. Okay. But there's an extra expenses here. There's this length contribution here. All right, so can you quickly compute what is this? Try and compute. Spend some time to compute this so that you get an idea what you were computing. Okay, can you try and compute what do you get? 2 pi plus 2 over 3. Okay, so 2 pi plus 2 over 3. Okay, no, cosine. Trigo integration here. Probably you need a substitution, integration by substitution. Okay, everyone good? Good. Okay. All right, so let's try the other parameterization here. So let's move this down, move these down, and then here. So what's the other parameterization here? So this is given, but after you learn the parameterization chapter, right, you should be able to work it out yourself also. Okay, you should be able to work it out yourself. You see, here say x equals to x, y equals to square root 1 minus x squared, right? To be consistent, if you like, you also can make a new variable t here. So such that x equals to t and then y equals to square root 1 minus t squared, such that t is going between minus 1 and 1. Okay, so this is like how we describe the upper circle. Okay. What do you think? Do you think that you are okay with x equal to x or you want x equals to t? What do you think? Which one you prefer? Huh? Which one you prefer? 还公平。t 哈，为什么？会比较乱。Yeah, so if 你会乱，你就做一个新的 variable 出来了。If 你不会乱，其实这个 t 确实就是 s 来的。Yeah. Okay, so it's fine. So, but to be, I mean, I cannot say to be consistent, but when we make it into t, we are reminding ourselves. Okay, we are reminding ourselves that we try to make the two variable into one variable. Okay, we use one variable to describe this two variable thing. This is possible only when you are considering a line. 只有线你才可以这样子做。If you have a plan, you cannot， 对吧？为什么不能啊？为什么不能 describe 一个 variable？I mean describe 一个 plan 用 one variable 啊，冰兄。再多一点。two variable 的意思是什么？啊？不是 plan 怎么有的？So line 有不同的 direction，也可以往前，也可以往后。这两个 direction 有什么差别？check you 啊，在 plane 的 direction 是怎样？Sorry，很多方向。OK，很多方向。很多是什么意思？多少多？他们啊，任意方向。哦，任意是多？从哪里选任意的？就是任意是哪边 任意 r 也有一个方向啊，也有整个 r，任意 z 也是任意啊，任意 n 也是任意啊。And why we cannot use one variable to describe a plane? And then what's about two dimension? Linearly independent direction. There are two linearly independent directions. Okay, so variable represent linearly independent variable. Okay. Okay. Yeah. Okay, so if you use this variable here, you can imagine that you will get what? You will get new factor, length factor here. So can we quickly compute what is the new length factor here? Square root of x prime t is what? So it's 1 squared plus, wow, how to differentiate this? Minus 2x minus 2t minus t over square root of 1 minus t squared. Okay, and this is going from where to where? Minus 1 to 1. Minus 1 to 1, right? Yeah, that's fine. Could it be minus 1 to 1? What's the direction of minus 1 to 1? Okay, let's compute finish first, and then we can talk about the orientation. Can you quickly compute this? What's this here? Let me see. Is it a bit complicated here? Quickly reduce this. I reduce this to 2 equals square x equals x. You see if you can simplify to here. Okay, can you see? 有吗？OK 吗？哎，不对啊，算错啊，有问题啊，有这个 verify simplification 错啊，有吗？哪里错？什么叫这么讲？就开罢了，就打开啊，就打开啊。因为 because you need remember you need to square something inside this square root, and then you combine. You make 1 into the denominator of square root, no square, normal square root. So 1 minus t squared. And then you take square root. Right or not? So here we'll square to t squared, right? And then if you make denominator the same here, the numerator will get 1 minus t squared. So if you add up together, you are left with 1. 1 plus 1 minus t squared plus t squared. Because this sign will disappear after squaring. 对吗? Okay. Yeah. So you should also get 2 pi plus 2 over 3 also. Okay, so what do you appreciate here? Can you appreciate from here? So you can see that this two integral is really different. It's really different. Okay, so obviously one have a trigger and the other don't have. And the other thing is when you do substitution, right? You do different substitution and also you come out with a different length factor here. Okay, but turns out that they compute to the same thing. But I think there's something wrong with the orientation. Recognize that there's something wrong with the orientation. There's something wrong with the orientation here. They don't orient the same way. Can you recognize? Can you recognize or not? Seems like they don't orient to the same way. 啊，哪一个是哪一个方向？第一个是这样转是为的，counter clockwise。Okay, the other 呢？anti clockwise. Okay, so can you make the clockwise one become anti clockwise？好像上次我们讨论过这样的问题，我讲做啊。S 等于负 t good，全部人可以 follow 吗？If you make this minus t, then you will go the same direction. But does this affect our integral or not? Why not? So if you put minus t here, so here become minus t squared. And then here also become minus 1 to the 2. Okay, so it doesn't affect. Okay, no? So should be, so I mean this, so we should put x minus x equal minus x 也是有一点怪哦。So I think OK，我觉得要把这个题目放掉。So pick a minus t here. OK，yeah. OK，yeah. So to make it into a same orientation. So from this example, you can see that actually line integral. So okay, let me put the upshot here. So the upshot here is the line integral doesn't depend on the parameterization of curve. The line integral doesn't depend on the parameterization of curve. Actually, you can prove it, but we won't prove this. Okay. Yeah. So to prove it, you need to assume two different parameterization, and then you prove that they have the same solution. Okay. Any question before we take a break? 哎，我好像很久没有看到那个川渝啊。啊，有人知道他在哪里吗？啊，一个礼拜啊。对，可是他上个拜五也没有在，好像。Yeah，有人知道他在哪里吗？不知道，你们都不是他朋友是吗？你怎么知道？啊，估计 OK。Maybe 可以问问他要不要来今天。Yeah，谁是他朋友啊？这里可以摇一摇他过来，他做一些 announcement 很重要。Okay, let's take a break until 10:05. We'll continue with a line integral later.
OK，看那个 project 了。
可以。
跟你讲，
有
是这样，我把它进去一个，做这个题，这个就是可以 我们最后要得到的东西是。
OK，就那个 OK，然后
然后这个是 general 形式的，就是这个是当这个比大很小，就是这个如果很小的话，
嗯哼
我们就可以用这个 data series，就是这个是 derivation 啊，直接看这个结果，得到这个是 period，是它来回的时间。
OK，什么叫滴答很小？你就它摇很小的时候才可以算到这个东西。
哦，没有，一大很小就是我把这个东西拉起来就是我没有拉太高，就是
不要拉太高，
不要拉太高。
但是这个小是多小哎？
就是我这边做的话是我让它趋近于零啊，看这里。
趋近零什么？就不要摇它
不是，就是其实物理上就是
啊。
它是很小的角度啊，可是这里
OK，
做推导的话，我是让取这个 limit，离大趋近于零的时候，
这个 series convert 是 prove 过了，
哪一个？
就是这个 series 等于
哦，这是 data series 的。
Taylor series。
嗯。
And then 为什么 Taylor series 等于这个东西？
哦
那是存在哪呀？
哦，这个是要看这个。
可是这个 Taylor series converge 在哪里啊？Sign converge everywhere。
那个是我用的是 Mercury。
我知道它 converge 在哪里，这个 x converge 在哪里？
什么意思？
这个什么时候 converge 这个 sign？这个等于是有一个 region 的 radius of convergence 的，
哦
所以发生在哪里？sign 呢？
哦，这些我没有
radius
只是写出来过，只是
我知道写出来，但是你要告诉我们
讲
radius of convergence of sin x 在哪里
意思。
？radius of convergence of sin x。
哦，可能用那个 ratio test
对
写。
所以就问你啊，我就用啊，你用，所以你要跟我讲哪里？
我没有实际算出来过，我
就是
写一个草稿啊。
我知道，但是就是要解决这个问题，你才可以解决后面这个问题，不然的话你等于不 make sense
可以。
啊。
嗯，
因为这个等于是要在那个情况下才可以等于，那个 radius of convergence 里面才等于。
就是我要写这个 x 的范围出来噻。
当然了，
对。
不然这个不 make sense，它不是可能不一定永远的 radius of convergence 嘛。然后，我要那边想一下，不是我的问题是为什么你需要看到这些东西？如果你只是，I mean，你用普通的 derivation 不是也是做得出这个东西？为什么要看到这种 Taylor series？有什么用？
简单来讲就是就是我要用到这个东西。
你是说 prove 这个啊？
对，因为我这边要用到是下从这个地方到这个地方。
这个是从哪里来的这条？
这个啊，
对，
这个其实就是你看拉起来嘛，就是
嗯哼，
这个是那个地心引力嘛，就这个后可以分解它。
这个懂。
分解它有这个其实就是它的那个恢复力，我不懂英文叫什么啊，就是哦是，
不懂
就是这个东西提供它恢复力。
，OK，就这样弄出来的。
这个是 definition 的，
哦，OK，
就这个有这个 F 面其实是有这个提供把这个，就这个其实是简单来讲，这个东西可以写成 k 乘 x， 这 k 是 constant， 就是好像
x 是什么？
x 是那个 distance，
哪里啊？你是
就是这里，所以我在取这个角度很小的时候就可以定式成这样子。
OK，我想一下啊，很小的时候是一个三角形。我想一下啊，所以那个减 mg sin 底大什么？
这个点 mg 现在底下就是我画的，就是这个是 mg 嘛，因为这边是底大嘛，所以说这里就拉过来这里啊， 这边也是 θ 角度，有这个东西减 mg，有一个减。
哎，喂，给我看一下，哦，是，哎喂，等一下，OK，
有这个减 mg，其实放减是因为它这个方向就是恢复力的方向，就是其实如果不要放减的话其实做分解吧。然后其实还有一个步骤我没有写出来，就是这个东西
MG 是什么
mg 是地心力，就是 F 等于
？MA，
MA，
怎么叫它 W？ weight 哦，叫 weight，
就是重量的意思。
OK，OK，
有这个其实跟这个我没有写出来，是因为它这个东西它没有往这里掉嘛，就它跟这个是 balance 啊，跟这个底是这个绳子，绳子提供啊。
OK，然后
然后就推出来。其实我觉得比较难的是这个部分，就是这个是那个 elipse integral first kind。
OK，
因为一个用到它是因为有一个步骤，就是这里的时候，我 change 这个 variable 的时候，我有这个东西嘛，然后这个东西，然后最后我要解决的问题是，这里，对，我要解决这个 integration，所以我就要先算出来这个是，要难点是要算这个出来，就要用 binomial series， 这个我把我草稿打出来罢了，它真的很长，没有这样短，只是可能不用把全部过程写进去里面。
对，或者就把它排在外面。我想想，所以你说你做这个 integration 是做这一个的 integration term by term，
什么意思？
就是你要对这个做 integral 嘛？
对。
等你要对这个做 integral，是吗？
对，给大家讲是因为这个都一样，
所以你需要 integration term by term 哦。
对。
所以你其实还是要讲那个 radius of convergence 的问题，这个东西是不是活在 radius of convergence？因为你是每次要等于一个 infinite series 的时候，你一定是就在一个 radius convergence 嘛，因为如果你想象那个 ex 的话，它在以外它就 diverge 嘛，对不对？
对，
每次你遇到 series 的这种问题，你一定要有 radius of convergence。还 OK 吧？应该 OK。你讲你有 differential equation 哪里有？哪里有 ODE？
我理解这边，找一下，这里，这边，就是这里，这是我没有打步骤打出来，
这样还好了。
这个就是其实有用一点 ODE，因为不能避免的，你是我
明白，那还可以了，不是来全部都是看它吧？
但是我觉得有些步骤应该是不用写出来的，就是普通计算。
对呀，
忘了写什么。
对呀，
所以这个题目其实 OK 吗
OK 啊，应该 OK，
可以，
应该 OK。就是你的重点就是放在我们学的东西了。
你刚刚讲是要写它的那个范围出来。
对啊，radius convergence，你每次写 series 一定有那个 radius convergence，因为它可能在某些 x convergence。
OK，对，那什么问题？
写了吗？你的题目？
但是大体上是这样。
等一下，我看一下我写了你的题目。这是什么啊？Spring 啊？你要
pendulum
period of pendulum。
对。
那么我好像记得以前来中学有读过这样的东西。
中学好像有。
他们是讲 derive 吧那种。
中学没有 derive 的。
哦，只是根据你 formula。对。 Okay.
Thank you.
那你讲需要几点啊？那我讲，okay. Okay. So before we start, I want to make some announcements here. So maybe some of you have seen these flyer before, the MAT flyers. I'm not sure how you think about it, but we're gonna change it. So I make a draft for it. So I was allocated to do this thing. So since you're my student, I can share to you first. Maybe you can give some opinion on this draft. Okay, I will share into your group, and then maybe you can give me opinion based on your study experience here, and also as a parents. Okay, so you should think about if you are parents or your parents, how your parents will think, or how your son who can think about it. Okay, yeah. Then you can give me some feedback to include or to revise. Okay, yeah. But I think Chinese students never seen this or no need to see this because you're coming through your China education system, right? Because you just fill in the form and then they allocate you. But for Malaysia is different, or for international students are different because international student, not include China student, is different because this university actually is a private university, 是私人的 so they need to do promotion so that people will come. 它不会像这种政府的 it's not like government university that allocates student. Yeah. Okay. Yeah. Okay. So I will let you see a draft first, then you can give me some feedback on it. Another thing is about your project too. I think Ken Pong sent me your draft, right? But I haven't read it. But now I'm gonna tell you more specific what you should do on your draft. So actually this project is kind of a very simple one. Okay, I want you to do it in a simple way. So there's really two sections you need. Okay, two main sections you need. One is a problem statement. So you need to phrase your knowledge about the application into a problem, into a situation, okay, that you can, like people will ask about it or people care about it. Okay, for example, Bing Xiong, what's your topic again, Bing Xiong? What do you do? Installment loan. And then can you briefly say what you're gonna like discuss there? What does it mean by principal payment? What is principal payment first? 借多少钱？所以你是说 you are saying that from how much you own, you compute how much you borrow? 还没去看完。Okay. So I mean, you need to phrase it in a normal daily life. For example, Isaac go and do an installment. Isaac want to know what's the principal value, something like that. Yeah, make it into a situation. Okay, and then after that, you just come up with the solution. Okay, and then in the solution you will include like knowledge from calculus 2, for example, series, parametric curve, partial derivative, multiple integral, so on. Okay, so in this case here, this guy actually involves some ODE. I mean, it's natural that our course has overlap, but you need to be aware that you need to put focus on this course. Okay, so you need to put focus on this course. So where's the focus here? So other than ODE, right? This solution has a power series form. Okay, the solution has power series form, and then you need to use term by term differentiation. So this one involves calculus too. Okay or not? So ODE is not the main point here. The main point here is how you use calculus tool, okay, to solve. Okay. And then in the end, what else you need? Just power series. So basically in this question, power series, and then got a ratio test law to see, because whenever you see series, you want to ask about convergence, you always need to know about the radius of convergence. Okay, so you will need the ratio test, the test for series test. Yeah, and then basically that's it. That's all. 就这样吧. Okay, don't write like too complicated, too complicated or too theoretical, because these two topics has a different flavor. So first topic, I want you to go full rigorous, okay, full rigorous. And then second topic, I want you to be more real life, okay, like explain to a layman, okay, 解释给一个不懂数学的人，但是你又 somehow 要用理论说服他，所以你要怎么去拿捏 how to like go over these how to go between these how to say I would say this is like a communication problem. So 你要讲到很学术，还是你要讲到不学术，但是又 somehow 有理论支撑。So you need to learn about how to communicate science. Actually, science communication is a degree. Actually, you know, 你知道吗？ There's a degree on science communication. 它就是研究怎么跟普通人 public 解释 science. Like public science you know like popular books 那种 on physics on maths 就那种科普。So it's a degree actually. Okay, yeah. So you will learn in this project and also presentation. You need to do oral presentation on this part. So I have a room for you. I make a announcement on Moodle. Oh, by the way, if you want to see how previous people do the project, you can look for it in the Moodle. Okay, in the applied version. Okay, you can go through. And I make the announcement here. Please take note. Your presentation will be held on next Wednesday, 9 to 11 in the morning. And it is at A3618. So do you know A3618? Have you been there before? 有没有人去过那边啊？没有哈。Yeah, 第一次在那边哈。Because actually I asked for this venue for like 2 semesters. The AA doesn't want to give me. 对噻，你有没有这样多人？你没有这样多人。And then 他讲你不重要，那是给重要的人。So this time AA give me， 所以代表什么？你很重要哦，现在哦，你是 VIP 哦。Okay, so please 为什么我一直讨这种东西啊？因为 I believe the university facility is for students. Okay, because you pay for it, you can use it. You should use it. Okay, if possible. Okay, yeah. Okay, no. Okay, ma. Yeah. So make sure you appreciate it. Yeah. Use it properly. Okay. Yeah. So there's one very interesting about this presentation section is you can invite your friend or your lecturer to come and watch you. And one very important part is Q&A section. Okay, so every ideas, every view should be challenged. Okay, should be challenged. Should be able to challenge and then you can answer. Okay, 如果你讲那个理论你被人家质疑过后你是不能回答的，你是不能够反驳的 ，then 你的理论就站不住脚。Okay, no. So you need to make sure that you can stand on your view. Okay, so you need to be able to communicate. Okay, no. So you need to learn how to answer questions, how to refute people, or how to convince people. And then the other thing is, when you ask question, you need to ask how do you ask question is also another art. Okay. Yeah. So how to ask question is also another art. So if you ask question to your friend, you get bonus mark. If you ask a good question, then you will get bonus. Okay or not? Okay. So bonus mark maybe can give up to 2 marks. Make sure you ask a lot of questions to your friend. Okay. Yeah. So you answer a question, then that part will belong to flexibility. How you go about answering people, or can you like understand the question by people or not? 很多问题在现实中其实说人是不知道你在问什么的，然后你会觉得他这么好像答非所问，可是他没有回答到我。为什么他没有回答到你？因为他就是没有听懂你在问什么东西。都没有听懂这个东西有2个方向，2个方面，可能问的那个人就问不太好了，所以他才没有听懂。第二个问题就是听的那个人没有听好，所以有2个。所以我们沟通的时候是双方向的，两边都要磨合。Okay. Yeah. So this is the thing we will train in presentation. Okay, no? Is it clear? Clear, no? Okay. So let me see. So far there are few topic that I haven't confirmed yet. For example, Yu Hon haven't gave me. And then Xiao Ying 昨天跟我讲了是吗？是什么 topic 啊？coffee cooling. OK， 好 ，coffee cooling。小杨呢？小杨 confirm 了吗？还是等一下你要跟我聊？OK，等一下再聊一下。常云呢？还没想好，下个拜三要 present 了哦。你今天想？OK，yeah。红杰没有来，还有一个 OK。So right. So I think I will try to make sure I give you your project back before next Wednesday, so that you know what to adjust before presentation and then before submitting project 2, where you will learn what to include inside project. Okay, I try to give you back next Wednesday, before next Wednesday, because I on the other class 2 assignment. And then before that, I was like marking your draft, right? Yeah. I'll try. Okay, I'll try. And then assignment, maybe I think the earliest is next week for the assignment 4. Assignment 4, right? You submitted. Yeah. Try and give you back next week. And assignment 5 is posted. Okay, assignment 5 is posted. So please start and look at it. And then if I haven't taught that question, try and read it first. And then when I reach that section, you can ask about some technicality that you want to know. Okay. So the reason why I put it earlier is you can try and preview first. Okay, preview what sort of question and then what is expected to learn. And then when I teach it, then you can ask me some technical. Okay. Okay, yeah. Okay. Okay, so continue. All right, so let's continue. Right, so next part is about the property of line integral. So let's look at the property of line integral first before we do this example. Okay, so there's one very useful property of this line integral here. Okay, let me remove. So there's one very important property here. So if your line integral is a piecewise move curve, okay, so what's piecewise move curve? So you could imagine that this curve is like piecewise is smooth, but maybe there's one point you cannot differentiate. Okay, and then something like that. and then joining a finite number of smooth curves. Then you can split out the sum into these piecewise, this piecewise curve here. So this is really similar to the to this additivity of double integral, right? You remember this property or not? Let me wait. So if you do this, or dA equals to double integral of d1. Still remember what's this property you use when you split out the double integral, okay, on the union of domain here. What is the condition on the domain that you can do this in double integral? You still remember? Right? The intersection of d1 and d2 is what? Empty, meh? Empty is one of the possible condition, but yeah. So this is equals to the finite number of okay. So can you see the similarity here or not? Can you see similarity here? Can you see similarity here? What's the similarity here? So in D1, D2, right, you should imagine like this D1, D2 only intersect in a finite number of curve here. But in this piecewise smooth curve, it intersect where? At finite number of okay. Yeah. So what I want to say here is, you see, the integral above a point doesn't contribute to the one variable integral. And then integral over a curve doesn't contribute to the multiple integral. Okay. Can you see the increasing dimension here? Can you see increasing dimension here? So if you take two-dimensional things, when you intersect, like last time we discussed, right? Two planes will intersect. At most, you get a line. And then if you take two lines intersect, you just get a point. Yeah. So if you are integrate over some, we call it manifold, okay, of a lower dimension, then you actually get a zero contribution. Okay, if it is finite number, if it is a lot, then maybe there's a trouble. But now in this case, it's finite. Okay, so if you intersect two lines, you get 1 point, and then intersect two-dimensional surface, you get one line. Okay, okay. Okay, yeah. So let's see how we use this. Let's see how we use it. So let's try evaluate this function here. You see that this 2x, this 2x function here, although you just see one variable, right? This is actually a two-variable function. Why? How do we see that? Because where's the integration domain lead? It is C, right? But this C here is working in R2. Okay, it's a curve in R2. So C here make up from C1 and C2 here. So how should you think about 2x as a two-variable function? Plane is a plane. So what plane is it? So to describe a plane, what do you need to tell me? Two ingredient, right? What's the two ingredient? For a plane. What's the two ingredient? Normal vector and what? And a point. What's the point? The point living on that plane. Okay. So basically, you just tell me a point, okay, and a normal vector, and then I can build the plane already. How to build the plane? I just take every vector coming up from this point here, which is perpendicular to this normal vector. Then this is the plane, correct or not? If you get any point on that plane, and then you can form a vector to this point here. And then this vector should be perpendicular to the normal vector. Okay, so you can get every point on your plane. Right. So this plane, okay, so this is a plane. Right. So let me see here. Right, okay, good. So in this case here, we got C1, C2, right? So, well, okay, since we want to do line integral here, but like what we discussed last time, this line live in R2, so we need to make it to live in R first. Okay, so to make it live in R, what do? You need to do parametrization. Okay, so how to parametrize it? So we try to split this integral into two parts. Why is it two parts here? You can recognize that this C is a piecewise smooth function. Okay, and then if you split into C1 and C2, they just intersect at one point. Okay, so it satisfies the property of additive property of additivity of the line integral. Okay, so what to do here? So let's do one by one. Let's do on C1. Okay, how to parameterize C1? So well, you could so this C1 here is what? Y equals to x squared from 0, 0 to 1, 1. So how to parameterize this curve here? So you can see that y is depending on x. Okay, so y is depending on x. So you can let x equals to t, and then y will become t squared. Okay. So where should we take this domain for t, the range for t? So you should take from 0 to 1. Okay. Because if you plug t equals to 0, you get the point 0, 0, and you take t equals to 1, you will get the other endpoint, which is 1, 1 there. How about C2? C2 is a vertical line. How do you find a formula, parametrization for a vertical line? How do you describe this curve? First, so this line is from 1, 1 to 1. So what's the graph? X equals to 1. Good. Okay, then if x is always equal to 1, what should you take for y? How do you make y run? And y should run from where to where? Huh? 1 to 2. Okay, so how do you set y then? T, okay, yeah, you set y as a new t here, so you make t run from 1 to 2. Can I set y equals to 2t? If I set y equals to t, what happened to my new range here? 1 over 2 to 1 over 2 to where? To 1. Do you think it will make a difference or not? If I pick a different parameterization here, do you think it will make a difference for the integral? No, right? So just now we discussed, right? If we put any parameterization, your integral should be the same. 如果不一样，代表什么？比较。假设算出来不一样，代表什么？ If you use different parameterization and then you get different answer, means what? There's only one possibility. 对，你算错。OK， 因为它是被证明过的，就一个可能性吧，就是你算错，或者你就是 parameterize 错，也有可能。OK 啊 ，So if I use this parameterization means what 啊？这两个 parameterization 的差别是什么？同一个 curve right，把它的差别在哪里？差别在哪里 ？Can you see what's the difference？ 都是走一样的路，都是一样的 curve， 把差别在哪里 ？What's the difference？ 一定有差吗？一个成了，一个没有成呢？它在哪里？跑得更快 ，Good，How to see？ 怎样看？跑得更快，看得到吗？就从这个四个东西吧，就看得出跑得很快了。怎样看？什么？哪里到哪里一样嘛，对不对？但是呢 ，Yeah，the time you use is shortened，有看到吗？ 一个1到2的相差是1，把1/2到1的 difference 是什么？0.5，更快，因为时间用的更多。OK 了。Yeah， 如果你觉得你不开心，你说，哎，我不要 start from 1，我不要 start from 1/2，可以吗？如果我要 start from 1加条，Yeah， 把 1/2，你就会 shift 你的刻度，等你也可以 start from 1咯 ，OK 吗？等你的时间就从1到1.5咯，那你就更好的 compare 他们两个，但是还是做一样的事情。OK， 可以吗？还是我写给你们看？Let's say y3 加 plus 啊，plus 在哪里 ？plus 外面还是 plus 里面？里面啊，里面什么意思？2 times t plus half 啊，这样，还是减？还是加？加还是减？来，我们先看一下，我们先做实验先。我们做实验看看会不会对。你们画 t equals to 1，我有没有拿到1这个点啊？对哦，所以讲调。讲调啊，such that this domain is 1 to 1。有办法调吗？哪里？去哪里 minus？给我一个整个 formula 看。2t minus 1啊。OK， 我们也可以 try 看。2t minus 1，what do we get？ t equals to 1， we get 2 minus 1, we get 1. Okay, and then x also, x is always 1 already, 不要管它。If t equals to 3/2, times 3/2 is 3. 3 minus 1 is 2. So endpoint 会不会一样？一样。Okay, so if you do this shifting, then you can see that the starting time they use is the same. It's 1 second. 你看到，哎，这个跑到3.2就3/2就停了，另外一个跑到2才停。But 他们的 endpoint 是一样的。Okay, so here I already provide you 3 parameterization here. You should try and integrate them. Okay, they should get the same answer. If you get the different answer, that means what? Your calculation got error. Okay. Okay, so let's try compute this integral here. So this one you can try exercise. We just compute one of them. So let's compute the integral of dx 2x on C, and we know that C is a union of C1 and C2, so we can split the integral up to 2 parts here. Can you see another reason why we split this integral into 2 parts? Because we have different parameterization of these 2 parts. Okay, so that's why naturally we want to split them up. Okay, so what's the first part here? So first part, we'll integrate from 0 to 1 on 2x. So 2x is just t, 2x, 2t. And what's the factor here? So you have a square root of x prime t, so which is 1 squared plus y prime t. In this case, we got 2t squared. And then dt. And on the other side, we have integral from, let's pick the first one, 1 to 2. And then what is 2x here? X is constant. So 2x become 2. And multiply by square root of x prime t. So x prime t is what? X is constant. So you got 0. And then y prime t, what do you get? It's just a linear function. So you get 1 squared on dt. And so second part is pretty easier. Everything is constant. So so in the end, and compute it using integration of substitution, and then you get some kind of complicated number here. Okay, so this number is not very enlightening, but to make it more interesting, go back and try and compute with these two parameterization. Then you should get the same. Okay. Yeah. Right. Well, I mean, there's one very interesting observation here actually. So let's pick up one of them. So there's one very interesting computation here. Let's look at this one. Let's look at C2 here. Well, I mean, what is C2 actually? C2 is straight line, no? C2 is straight line. And then, what is the area of a C2? What do you think? You see, when you substitute x equals to 1, the function become constant or not? C2. Meaning what? All these points have the same height. Okay, if all these points have the same height, height of what? Height of 2. Means what? What's the area you're computing here? What do you think? Hi, Wei Chen. You have a straight line, and then every height for this line is the same. So if you try to compute this area, what is it? Rectangle. Also, basically, is the area of a rectangle on C2. Okay, so one way to compute this, how to compute this area of rectangle? 2 times the width. So what's the width here? 2 minus 1. So the area is 2 here. So let's look at this closely here. Do you get 2 from this integral? No? You also get 2, right? Okay. Yeah. So sometimes you can use the knowledge we learned before to compute without going into this x prime d y prime thing. Okay, no need to do that. Understand or not? Yeah. 懂我在讲吗？有时候你可以直接算它的 area， 不需要来一定要用这个 formula。But obviously, this formula will give you the same thing. Okay. Okay, any question so far? 有问题吗？ Okay, yeah. Okay, 继续。Next, we try to split out line integrals here. So this one very important thing is this part here. It's no longer ds. We split into dx and dy. Okay. So this is, you need to compare with this function here. Yes, yeah. So meaning we are not differentiating along the whole line. Okay, so we're just differentiating along some direction. Okay, the x direction of that line and y direction of that line. Okay, so meaning what? We just look at the changes in y for that c and the changes in x for that c. We are not looking at the combination. So what happens here? So what happened here is when you do this, the factor here change. The factor here change. Does it make sense? Why this y x prime and y prime? Does it make sense? Why? So let's write down the usual one first. Does it make sense? Can you make some sense out of it? Out of what we have learned just now? How to see what factors stay? You make some sense out of it? Yes. So if you just look at change in x, meaning what? We view y as a constant. So y prime is 0. So square root of s prime t square is just x prime. Okay. Obviously, to prove it, you need to use definition. But this is one quick way to see it. Okay. Yeah, this is one quick way to see it. So remember, when you do with respect to dx or dy, you need to have an extra factor of x prime t or y prime, respectively. Okay, so this is very important. This kind of line integral, we will use it in the Green's theorem later. Okay, all those vector calculus. Right. So let's look at this. So now you are asked to integrate this line integral with respect to x and y. Okay, it's not ds anymore. We split it up into s direction and y direction. Okay, so this is a different object now. Cool. So let's try. So what's the similar thing we learned is you still need to parameterize your C because your C live in R2. So to do one variable, you need to introduce parameterization. So let's do two calculation here. So there are two paths given here. Right. So can you try and parameterize C1 or not? How to parameterize C1? C1 is a straight line that joins 2 points. Can you get a formula for this line? How do you get a formula for this line? What's the formula you can use? Straight line joining 2 points. 来，说 Isaac，每次看我会吗？讲来讲。是这样啊 Okay, so what do you get here? Y equals to x plus 2. Okay, so you look at the ratio okay, between 2 points. And then what's the xy here? What's the xy here? The xy here represent all the other points on the line. Okay, so basically you are looking at the ratio between 2 points. What's the ratio there? The ratio is about the difference of x and difference of y. Okay, so you get that this line is what? Has a gradient 2, correct or not? Direction, correct? Okay, positive gradient is this direction. And then the y-intercept is 2. So you can see that equals to the y-intercept. Okay, right. So what's your parametric equation in this case? So what can you set your SS? You can set your XS, T, and then Y depend on X. Your T going from where to where? Minus 5 to 0. So make sure you check. So do you get the endpoint and starting point or not? If you set T equals to minus 5, you get minus 5 plus 2 is minus 3. And then T equals 0, you get x equals 0, and then T equals to y equals to 0 plus 2. OK，有没有人想问啊？为什么我不要 set y 等于 t？可以 set y 等于 t 吗？啊 ，so OK, so let's write these as C11 first. Let us try C12. Can we instead set y equals to t? If we set y equals to t, x equals to what? What? T minus 2. Then will it change the range of my t or not? Will it change the range of my t? Minus 3 to 2. Yeah. So, well, I mean, as long as you get this dependent here, you can set either one variable. Then the other variable will depend on the other one. Okay, this is exactly what this equation tells you. Y is equal to x plus. Okay. Okay, so there are two parameterization here. So one homework you can do is after we compute one parameterization, we can go back and compute the other one. They should give you the same answer. Okay, so let's use the first one to compute. Maybe you can start compute already if you remember the formula. Yeah, so how do you compute this? I haven't really tell you, right? Can you split them out? Can you split out the sum or not? Actually, you can. You can split out the sum. Okay, so you can split out the sum. Okay, you can split out the sum. And then you do the parameterization. And not that you see, I see my writing here. Previously, I just put y, but in the next step, I put yt, meaning I substitute y by t already. Okay, so when I put y in terms of t, I substitute this y in terms of t. So if you do that, what's the substitution? In case 1, we have t plus 2. And then what is s prime t here? So it's a linear in t, so the derivative is 1. So we get 1 plus of t dt. Also, the derivative of y is 1 also. Okay, I think this integral is kind of easy. What do you get here? You should get minus 5/6. Maybe you can quickly compute, see if you can mesh up or not. Let me provide you another parameterization of this line. Kind of useful. Useful here. So what's the other way to describe a line? Remember I told you that what's line? Line also built up by two things, a point and a direction vector here. Okay, so you can describe C1 as a point plus a direction vector times t. Okay. So how to get this direction vector here? Well, I mean, how to get this direction vector? It's the same as your, is it the same as your gradient, right? Okay, it's the same how you get your gradient, similar to how you get your gradient. So what point you can pick here? So your line start from -5, 3, -3. Okay. And then how to get this direction vector? Any idea? How to get this direction vector here? Slope? Vector what? Slope is number. How to get this vector? Do you remember how to do vector calculation or not? How to get this vector? Do you still remember vector addition? Vector addition. If you add two vectors together, what happened? How to get the resultant vector? To get resultant vector. Let's say I give you u, v. How to get this resultant vector here? V 减 u. You can take, u, u minus v. How to see this? 讲看这个东西 So you need to see what you want to find first. From where to where? From this point to the other point. I mean, from the endpoint of V to the endpoint of V. So how to work? How to work? Where you start? You start with the endpoint of V. So what does it mean by start with the endpoint of V? V start from where? V start from the origin. But you want to start where V ends. Means what? You need to take minus V. Okay, so you take a different direction. And then you walk to U so that you can start from the endpoint of V and then end with the endpoint of U. Okay, so in this case here, where's your starting point and end point? So the starting point is -5, -3, endpoint is 0, 2. So how do you like make this a direction vector using these two vectors here? So 题目 is how to get the direction vector, how to get the vector of C1. Just now I tell you how to get U minus V, right? So how can you apply to this case? So you need to determine where you're going to start, where you're going to end. And then change direction. So which direction you need to change? So let's give name. So give this one V1, this one V2. So what is C1? The question is, what is the direction? What is the vector for C1? You should know to try. Try 啦，跟紧啊！一定要在榜上 try，不然回家更难 try。什么？C1 equals to what? Minus V2 plus V1. So let's see what happens if I do minus V2 plus V1. So minus V2 says what? I change the direction of V2. So I go from top to bottom and then I walk to here. So what's the direction here? You go from top to bottom. So it's opposite. Since you already get opposite, how to get the other opposite? Opposite, make to the right one, right? So instead, you should take minus V1 plus V2. Yeah. Okay or not? Okay, so instead you should get V2 minus V1. So if V2 minus V1, what's the answer? V2 minus, sorry, V2 是02 minus -5 minus 3 times t. Instead, you get 5 by 5. Okay. Okay or not? 有问题吗？ So one thing very important is vector have direction. 这个就是 direction 的意思哦。你从哪里开始，哪里停很重要。虽然都是一条线来的，但是哪里开始哪里停，已经告诉你是 direction. Okay. Yeah. So in this case here, what's the new parameterization here? What's the new parameterization here? X equals to -5 plus 5t, and then y equals to -3 plus 5t. So in this case here, what is the t here? What do you think? The t should go from 0 to 1. Okay, yeah. Okay or not? 可以看到发生什么事情吗 ？Everyone, can you see why the t changes 哦？时间不一样去。Can you see? In 3 parameterization here, the time is different. Can you do some interpretation on these difference of variable? How do you parameterize in first way and second way? Okay,
How do you parameterize in the first way and second way? Actually, the first way, how you parameterize those points is using the x coordinate. Just x coordinate. Your x coordinate span from -5 to 0. So your t also run from 0 to -5 to 0. But in C2, you parameterize using y coordinate. So that's why your t is run from -3 to 2. But in this case, you try to make your line into a arc length parameterization. Okay, so you start from 0 to 1. Okay, so you take your time from 0 to time 1. Okay, to complete the term. Okay, to complete the line. Okay, yeah. So that's why in first way and second way, sometimes people just write x equals to x. And then second way, people write y equals to y. Right? Because you are really using x coordinate to parameterize it, and then the other one you use y coordinate. And then this one you use different way, the time starting from 0. Okay. No?
Okay. So one exercise you could do is check all these give you the same answer. Okay, so try and go back and compute. Before we break, I think we can do one more. So let's do one more before break. So in general, if I give you a parameterization, you can see the orientation like what we did just now. You can go from left to right or right to left, depend on your parameterization. Correct or not? Just now, still remember the upper circle, right? If I put t, then it's counterclockwise. Minus t become clockwise. Okay, change your orientation. And does it matter or not? It does matter actually. It does matter. So if you if you change your orientation, right? Usually, if you integrate over opposite orientation, you should get minus of the original minus of the original integral. Then it does matter actually. But I think the question that we did just now was symmetric in x, so it doesn't matter. In general, it matters. Because the question just now we have x squared right inside there, so it's symmetric around. In general, if you change the orientation, you get a negative sign. How to get a negative sign? It is a negative of the original orientation. Okay. Yeah. Any question? Any question before we break? Anyone? Okay. If no question, let's break until 11:10. Yeah. OK，
其实昨天
可以，
那个它是一个这样的问题，假如有一个场景，它的区别可能是这样，在这一点上，就是列出来的，然后写算出来是加速度，它加速度是就这样，是最后一个是这样，是0，其实所以说这个方程是什么意思呢？就是这个小球你放这个顶点上，就我们常识是它会在顶点上不动，没有关系。但是这个方程就是招式，它可能就是随机静止那个大写 T 是这样，然后在大写 T 之后突然的开始动， 嗯哼，
是，
嗯哼，
但是我想了想，
嗯
好像不太行。就看了一下后续，好像这个结果也没有什么定论
，OK，
什么的。
所以你要换还是
就
换咯，OK，可以，
然后之前我还看了一个，就是那种
嗯
计算那个航天器材，
嗯
就是在升空的时候，就是各点那种温度的那种
，OK，它用到什么东西？
三种积分。
它有3种积分，OK，
对，
OK OK
而且拉格朗日点那种
OK
啊，
OK OK，
就可以用，
3种积分可以啊，
可以。
3种积分可以
就这个。
，OK，你可以再写给我，你再写给我那个题。哎，
presentation 每个人有多少？
哦，多长啊？OK，等一下我再说一下，再提醒一下。哎，所以你的那个你的 draft 能不能跟着我刚才讲的东西改一下？我看一下，就是说不需要分到太多东西出来。其实有一个点对于你的这个东西是，我不知道什么叫 white noise，你没有去介绍它，然后忽然间就提这个 white noise 出来，就我不知道在讲什么。I mean 前面 make sense 啊，就是说你觉得有 noise 吗？然后忽然间就会有 white noise，还是
没有，主要是它 noise 分为很多种。
所以你要来介绍了，
如果说
你要用的东西，你一定要把它介绍出来。如果其实 white noise 对于这个讨论没有那么重要，其实 noise 就好，就不讲 white noise。
但是如果说我要
嗯，
general 到整个 noise 的话，我的那个东西会变得挺复杂。
那你要就是你自己要来 introduce 啊，无论如何啦，就是你就要讲这个过程啊，就是说可能我们不要讨论 white noise，但是我们讨论 white noise，然后为什么，然后就这样啊。但是至少你要讨论，不能突然间说就 noise，因为很复杂，但是我不要跟你讲很复杂，我直接讨论完，不可以这样吗？对不对？对，这样。
我在想，就是因为我们最好是加一个那个，就是我们在演讲的时候，我们是直接就是照这个讲，就是说需要用应用，比如说我找一段音频来，然后我自己的
都可以，那个是看你自己的那个创意，那是看你的创意，但是时间就有时间限制了，然后创意就无限。
这样。
好，哎哎，
肚子特别
哦，OK，
一个是肠胃
哦是啊，好，这样的话，让他回去看 recording 哦，因为有说关于 Project 2的东西。
Okay, so actually, I put all the details in my course info if you want to check um, what's the criteria. So let's remind you again. The presentation actually is just 1 minute. I can give out to 30 seconds if your presentation is really interesting or worth to listen. Otherwise, please keep your presentation in 1 minute because you are just really presenting one patch of things or nothing much. You know, there's a competition called 3-minute thesis competition. You know that? So most of the university have something called 3-minute thesis presentation competition. And that thesis is a PhD thesis. So usually PhD thesis is like 100 pages. So they need to tell people in 3 minutes. Okay. So we are doing something similar to this. And we put more times in Q&A section actually. So like what I said last time, I don't train you to do maths. You need to speak maths. Okay, you need to speak, able to speak your language out. Okay. You cannot people ask you then you cannot tell your ideas properly. Okay. And then the other important thing is you need to answer 2 questions here. Okay, how do you convince the layman 知道什么是 layman 吗？lay person 就是说一个业余的人，一个外行人，layman，你怎么能够说服一个外行人说数学是有用的？当然，你要说服外行人的时候，肯定要说服你自己先。可能你都觉得数学没有用，如果你都觉得数学没有用，你想说服别人，所以你一定要说服你自己先。怎么说服别人其实很简单，你要先说服你自己，你能说服了自己的东西，你才可以说服别人。如果你连自己都说服不了，你怎样说服别人？别人就觉得你这个东西没有力。Okay. And then second is I want you to think about why you first choose to study here or maths degree. 可能你是被你父母逼的，父亲逼你，一定要来这里读靠近家还是比较便宜，或者说有奖学金。But 你还是要找一个你自己的动力。我记得我以前读 A level 的时候，那个数学老师胖胖，一个女生，有点严厉。他第一天呢还没有教我们数学，他给我们每个人一张纸，小纸，他说写下来 你对你 A level 数学的目标是什么？A 加 A 啊，A 减啊，B 啊，还是什么？还有写下来，读完 A level 过后你要做什么工作？我记得我那时候写的是 pharmacy，你觉得我现在做 pharmacy 吗？pharmacy 叫什么？药剂吗？你觉得我现在是药剂师吗？不是哈，很清楚嘛，因为我之前是在讲书了，所以就是说什么，这个目标不是说你想过后你一定要做的，不一定，但是就是它是一个你的动力，那你可以持续跑的一个动力。如果你说，可能我不知道我对什么学科很兴趣，我只会算吧，没有只会算。Then，大学的数学不是在算，所以你会觉得你很辛苦。说你要找一个更好的理由去说服自己，让你自己有动力去。因为我不是要骗你，我不是要害你，我不是要虐待你，你知道吗？因为这个数学就是这样。OK，如果你真心认为你读错，放跑道，正常的，放跑道吧。OK，你不需要再待在这里自己虐待自己的。OK，但我可以confirm给你的是，如果你能够从这个数学系毕业，你会得到一个在其他学科得不到的一个知识或者一个能力。OK 吗？Yeah. So I want to make this very clear to you. OK，我也没有想跟你树立什么敌人这样。OK，I mean 我就是要来传授这些知识吧。如果你接受不了，你不能接受，it's OK，正经的。但是如果你接受得了，这知识是属于你啊，又不是我的，对，这是属于你的能力，你可以拿去赚钱啊，拿去做什么，最好不要拿来做坏事就对了。哎，这个能力很容易做坏事，你知道吗？你知道以为啊，你知道什么叫 KK 元吗？Does anyone know KK 啊？诈骗，对，在缅甸有一个园区叫 KK 园。I think nothing to do with it 嘛，不要等下讲我诽谤的，我没有啊。把这个 KK 园哦，你可以想一下，为什么它可以来逃脱这种政府的管辖啊什么之类的？它里面是有一个很强的手脑或者一堆人在那边的，你明白吗？如果你脑很厉害啊，千万不要去做这种事情，去害人啊，OK 了，做一点对身边人有用的事情。OK，Anyway，OK 吗？Clear 吗？Presentation 要做吗？OK。Yeah, another thing is maybe you want to show video or you want to do some practical thing，可能你要带一些器具来，it's OK，你都可以做。Creativity 是你自己想的，但是我就是给一个时间限制吧。OK，随便你要做都可以。你要带我们出去玩也可以，都可以。OK，对，OK 啊。So marking criteria is language completeness and flexibility. Okay, so you can earn extra mark if you ask a good question. OK， yeah, so 还有问题？哎，应该没有时间问了哈。下一个拜三就是了，没有什么时间问了，所以有什么可以尽快问，不然下个拜三就 present。其实，在 lecture 之前，我们不会再看到 before，before presentation。Okay, right, let's see. So, so same thing. If you want to do line integral in 3 spaces, you can, generalize what we did before. So you can see that the length factor there increased by 1 derivative. And then you can do similar calculation. I think we don't want to go through this. You can do as homework. Just add one more variable. Okay, no? Yeah. So similarly, you can do additivity of integral in 3 spaces. Okay, I mean 3 spaces mean R3 lah. 3 Horn spaces. Okay, 3 dash spaces. Euclidean space of 3-dimensional. Okay. So in this case here, then the formula of line equals to points plus direction vector times t becomes useful, 对不对？因为你的 three variable， 如果你再去做那个什么 y 减 y s over s d， then 你要做好几个，是吧？ In this case, it's better you use the general line equation, which is what? Point plus a direction vector. Okay, in this case, 对不对？ Yeah. Otherwise, you need to make a few gradient equation of it. Okay, no? 有问题吗 so far? 有问题吗 Okay, we left this as an exercise. You can go back and try. Okay, if no question, let's continue. Next, we will learn word done. Okay, so word done is a kind of line integral here. I'm not sure how many of you learn physics before. If you don't learn physics, how to memorize word done? 你做了多少的功？怎样证明你有做功？啊，头痛？呀，对，怎样证明你有做功哦？奇怪了，怎样证明你有做功？如果你一直推，我有推，不动，你做到功了。你的老板会讲你做到功，我推了，不动，做到功了。啊，你做到功了？没有 ，zero word done 哦。所以你看 word done 是 force time displacement， 你的 displacement 要动 ，you have to have some displacement non-zero displacement， 你才有做到功 ，OK 吗？你可以往前推，你也可以往后拉，对不对 ？positive negative 都有功，方向不一样 ，OK 吗？但是如果你有做功，但是没有改变哦，那你就是没有做到功。这样子的意思是什么？对，你的 F 真的有放进去，但是你的 S 永远是零，证明什么？你是白做工，是 Trump， 是美国总统，做白工，你是做白工的 ，OK？ 说跟你读书一模一样的，跟你读书一模一样。你说我很努力读了，结果成绩negative，我操！哇，这更死哎，比没有进步更惨哦。做什么工？不公正哦，那个地工，so 你要用你的 displacement 去 check 你自己哦，你的做的东西跟你的得到的东西有没有匹配？没有匹配，就代表你要调了，你的方法要调，对不对？你的 force 怎么运用 ？OK， 所以那种很聪明啊、很厉害的人呢，其实他们就是 efficient 嘛，他们就很 efficient， 真的就很 efficient 啊。比如说，我们可以讨论打羽毛球，打羽毛球。怎么我打不起来了？怎么我打不到奥运会了？因为我打一下我就累了啊！李宗伟打10个小时都不会累啊，你明白吗 ？You understand？ 所以就是 depend on 你的 force 怎么去应用到 efficient， 越 efficient 你就越好。Obviously， 你不是一个专才的话，你就要训练，你就要自己去调，每一个方向你都要调，明白吗 ？OK， 但是你真的要调，这个是 I mean。每个人自己要去调。But you can check whether what's your displacement. Okay, so how is it related to a line integral here? So usually this displacement here is what is this? So where do we start? We start with a vector field. Okay, we call it a continuous vector field here, force field. They call it use a physics word. Maybe if you don't like, just put vector field. So continuous here refers to what? Continuity here refers to what? So it's a continuous. This F1, F2, and F3 are continuous. But this F1, F2, F3 is a scalar field or a vector field? Scalar field. Okay, so this F1, F2, F3 should give you a number. Okay, so 3 number in different direction make up a vector. Okay, yeah. So basically you use scalar field to describe, to define a vector field. Okay. And how do we compute this work done? So let's call our curve C and then parameterize by RT here. Okay, so we integrate over C and then with respect to the change of dr. And similar to what we had just now, you will get a contribution of r prime t here, dt. We won't derive this. You just remember. So what to remember here? Remember this part, this line, and this line. Okay, so remember this two of these. Tangent line is important. Maybe not important for now. So let's just remember these two lines first. So how do you compute work done times x? So you see that this is really work done times x. This is really force times the distance. Why is there an integral there? Why is there an integral there? 怎么有 integral？ 不过乘一下就好了，怎么还有 integral？ 啊？对吗？
程度它只是所以一个点点点，把全部点的加起来。
对吗？你要加吗？
那个写的那个
没有啊，你 dot 的那个 product 那个 displacement 是一个长度来怎么这个长度要 integral？
因为它只是看它 dr， 然后只是看小小个，我就要把全部每一个的加起来就变成。
为什么我们要看小小个？这个问题是？
因为它一直都在变。
差一点点。为什么它一直都在变？
也太可能。因为它可能好像叫你推椅子这样，推一下上面，推一下下面，推。
不太对。怎么样推上面推下面？这样？这样不是。So the normal work time displacement is just in one line， 直线吧。But in real life 你的 R 是这样的。去讲算这个弯线的长度 ，how to compute the length of a curved line? You need the integral, so that's why there's an integral. Okay, because the C you consider usually is curve in R3， 对不对？如果弯的话，我们讲算，我们要拿那种无限的词来算，对不对？但是它能够 ，then it make it into an integral. You need to compute the limit from 0. Okay. And the result, the end result here is this end result is the one that's useful for you. Okay, which is more useful? Because F1, F2, F3 is what? Is the formula for your vector field. And then you just integrate with respect to x, y, and z. 对吗？你看这个 x, y, and z 有讲究的哦，它是 pair with the right scalar field. F1 pair with dx, or we don't pair F1 with dy, we don't pair F1 with dz. Okay. We pair F1 with dx, F2 with dy, and then F3 with dz. Why? Because 1, 2, 3 correspond to the 3 direction. Okay. So meaning what? There's no contribution of F1 in the y direction and also in the z direction. There's no contribution of F2 in the x direction and the z direction. And similar for F3. OK 吗？明白吗？所以意思说你要算在 x 走了多久，在 y 走了多久，在 z 走了多久，其实就是 depend on 你的 vector field 在每个 direction 的那个方式是什么。OK 吗？有问题吗？还是有想法吗？ I didn't tell you the derivation. I just tell you how to remember. Okay. 我没有 proof 给你啊，只是告诉你讲记吧。Okay. Understand? 可以吗？合理吗？ Okay. Let's do one computation. So like what I told you last time, right? Why vector field can induce would done? Because if I put a particle in this vector field, this particle should flow with this vector field. Okay. And then once the particle flow, it will induce a displacement. Then you can compute the work done. Okay, you can compute the work done. Right. So let's see what's the work done by this vector field. If you want to move this particle along this path here. All right. So how to do? So this vector field have two components here. Okay, two components. It's a vector field from R2 to R2. It's a vector field from R2 to R2. And then we already parameterized this curve here. So what's this curve here? So how to parameterize this? So let's set it to be. How do you want to set it? So what's your S and Y in terms of T? Any idea? Okay, so the X coordinate should be cos T, and then Y coordinate should be sine T. And then T going from 0 to power 2. So what's the word done here? So one way to memorize a word must be first time displacement. Okay, but we're gonna do it in this continuous way here. So the word done will become the integral along this curve f dot dr. So you see this dot here is really dot product. It's a really dot product here. Okay, it's a real dot product here. But I didn't tell you the derivation, how to compute this. You make this into the line integral with respect to different direction. Okay, so you see, we turn it into a one variable case again. Turn this two variable case into one variable case again. Well, I mean 这边如果真的要写出来，你知道是什么东西吗？其实我可以一般 proof 给你看的。其实，如果你这边写出来 f 是什么，x square 减 xy dot with dr，dr 是什么啊？我们把 r 写出来了嘛，对不对 ？differentiate 这个vector function， 还记得怎么 differentiate 吗 ？differentiate term by term， 所以我们拿到什么？sin t 啊 ，minus sin t，OK good， cos t good。So 如果我把这个 ，well I mean 这个是什么东西哈？哦，这样我要告诉你什么是这个先。So what is this? Is it enough to tell you this or not? Oh, right. I think we should leave out. We still have. Let me think. 我们是不是少了一些东西啊？DT 啊，我在想 DT 要丢去哪里？DT 应该要丢在外面，是不是 ？Because let me write down here. 快啊！So dr dt equals to r prime t to 减 sin t plus t。OK， so 我们再做一个 illegal 的这样子的东西。Yeah. Well, okay. Okay, so
if you split this out 啊，这个真的是我们刚才在做的事情。等一下我会再证明给你看一次。虽然这个证明是用 example 证给你看的吧，你可以看到为什么那个 formula 是那样子写。Okay, so let's say this dot product compute to this number here. So how to compute the other side? 先算算其他的 side 先。So what is integrate c over dx? What's this here? 可以来考我一下，温习一下上个小时讲的东西。So, if you integrate f1 with respect to c dx, what do you get? Your domain is going from 0 to power 2. Your f1 is what? X squared. Remember, when you change to dx, what do you do? What do you do? Yeah, there's a s prime t, right? S prime t dt there. So s prime t dt in this case is what? Minus what? Sine t dt, okay? And then plus what? Similarly, you do it on the y direction. The y direction, what do you get? Minus xy times y prime t. So y prime t in this case is what? Sine prime t. You get cos t. Okay. So you can see that 两边其实就是算类似的东西。But you see, inside the integral of t, you have x and xy. What do? You need to substitute your parameterization. Okay, make everything into t before you do integration. Okay. Okay, I think we won't do this integral, so you can try and finish it. I think you will get minus 203. Okay. Any question? 没问题吗？没问题吗？ Okay, so somehow I use the example to tell you how the formula appears, how the formula appears. Because when you do the dot product, really only x direction will match with the x direction and y direction will match with the y direction. There. Okay. Any questions so far? Okay, if no question, we can keep continue. See what question is this? See what's direction? Okay, so this question is a bit tricky. This question a bit tricky. So what should we do here? So okay, let's do this question. So this question will use the first way to compute. So why is it using the first way? It's convenient. You don't need to find the parameterized curve. What do you mean? I don't need to find. Actually, you can do also. Okay, let's do it. So this curve is described by t in the first variable, and then t squared in the second variable, and then t cubed in the third variable here. Okay, so if you use the first way, like what I did just now, you can straight away differentiate this guy here, where you get 1, and then 2t, and then 3t squared. Okay, for all the 3 terms here. Well, you need to note that your t is going from 0 to 1 always. Okay. And what's your f here? So our f is given by xy So how should I put this? So f is given by xy, yz, and zx. Okay, let's say if we want to make it into t, variable of t. Everything make into variable of t. All right, like that. So I make everything into t. So can you see that if I make everything into t, it's a very nice, nice function on this curve. Okay, because in every direction it's just a power of t. So you can see that this function here reduced to the function of power of t. So you can see that first one is t cubed. So how to get this? So you just put t, x equals to t, and then y equals to t squared. And then y equals to t squared, z equals to t cubed, and then z equals to t cubed. X equals to t. Maybe you wonder how we get these. Basically, if you're gonna write this parameterization with in the other form, well, I mean, so let's put it here. So let's put a different, the second type. So let's say this one is C1, here C2. So you should let your x equals to t. And then how should you let y? Y is just t square, correct or not? And then z equals to t cubed. Okay, if you want to write it in this way also can. Okay. Yeah. Basically, the RT, what is the general way to see these? RT really tells you what happened in X direction, in Y direction, and also in the Z direction. Okay. Yeah. Okay, ma. So far, so good. Okay. And if you want to compute this line integral here, okay, what do? You just take a dot product between f and dr. Okay. And then time dt. Where's the t ranging from? So t go from 0 to 1. Okay. And then you can do this computation. Or you can do the splitting up, right? You can split to 3 direction. You can do f1 on dx, and then f2 on dy, and then f3 on dz. That should be the same. Okay? So one exercise you could do is you compute two ways. You should see that they are the same. Okay. Any question? So I'll go back and try compute these two ways here. Okay. Okay, so before we finish off, let's discuss one more idea and then before we break. So, okay. So one idea is, in calculus 1, you learn something called FTC, right? So what's FTC? Fundamental theorem of calculus. So what's the statement says? If fx is an antiderivative of fx. So what does this mean? Antiderivative. Derivative is prime, right? Differentiate. So what is antiderivative? Meaning the derivative of f, capital F here, is the small f. Okay. On the interval I in R, then for any AB in I, what can we do? We can try and compute the integral of this small f here. But how do we do it? And it's just try to integrate this f prime x.
Not because capital F is the antiderivative of F, but what is this?
So this is the main point here. This is the main key point 啊，你中学做的那个 integral。为什么算到最后哦，你就是 sub 一个头 sub 一个尾减一下就好，就是这个 theorem 告诉你的。You just put capital F applied to B minus F A， 这就是你做的那个 integral 最后一步，最后一步，对吗？对，就是那最后一步，头跟尾减一下就是你的答案，这个就是那个 fundamental。OK， if what if 如果你里面 differentiate 的，sorry， if the thing that you integrate over is the derivative of the capital， yeah， 所以其实我们的算法是反着做，不是？我们是拿到这个，然后我们去找它的 integral。其实 theorem 是说有了这个，它可以 differentiate， 我才有这个东西。You understand 懂吗？在中学不是你在算这个东西的时候，你是有一个 integration 的 formula 告诉你怎样去找这个 capital F， 但是这个 theorem 告诉你说什么？这个 capital F 可以被 differentiate 过后，才可以这样算。啊，当然顺序了，顺序的差别。OK， yeah， 所以为什么你中学可以那样子做？因为有这个 theorem 在，它是先可以 differentiate。然后你在算这个 integral 的时候，才是用那个所谓 integrate 出来的那个方式来算。OK， okay, so we're gonna generalize this to a line integral. So can you imagine how to generalize this to line integral? So how to generalize the derivative of f? How to generalize this? Also note that our function generalized to two variable. Then 什么 derivative 我们讨论在 function of two variable？ 我们的 gradient 变成可以用 gradient 吗？还是我们的 slope？The slope will become a gradient in two variable， 对吗 ？Gradient for function of two variable is a vector field。现在只是一个 scalar field 吧。Then you will make a vector field out of it. So let's introduce the statement here. So we have a similar theorem. If C is a piecewise smooth curve, okay, parameterized by RT, and F is continuously differentiable on an open set that contains C. So open set here is a technical property here. Basically, you won't use it. And we already discussed open set, right? Last time. So you can imagine there's an open ball containing this curve here. Then, how do you compute this integral here? So you should imagine this gradient here as the derivative, F, okay, in the one variable case. Then what do? You also take F applied to the endpoint and then take their difference. 也是一样 ，OK， 也是一样的 in 这个 case. Maybe we quickly prove these and then we will do exercise next time. So how to quickly prove these? This is a very nice proof I can show you here. A very nice proof here. So if we start with left hand side, we're gonna end in the right hand side. So what's this left hand side here? So we're gonna use parametrization, okay, just now. So we parameterize the curve into one variable. So let's start from A to B, and then we replace my gradient on the line itself. If we do parameterization, one variable, there's an extra condition you incur, right? So you dot product with R prime T like this. Okay, so what are these? So you can really write them out. So if you write them out, it's del f over del x, del f over del y, and del f over del z for your gradient. And then on the other side, it's really just dx over dt, dy over dt, and then dz over dt. Okay, so in this case here, maybe you are a bit worried where I get these XYZ here. Really, we just set RT equals to XT, YT, and ZT. Okay, because RT is a vector function. Okay, it gives you a vector. So one thing you need to differentiate is vector function, vector field. 这些字眼你要分辨一下. Okay, vector function says what? Codomain is vector. Okay, typically it's from R to Rn. Vector field, make sure when you see vector field, you have to have the same n on both sides. For example, R2 to R2, R3 to R3, R4 to R4, like vector field. Okay, so if you do this dot product, what do you get? This one's, have you like, are you familiar with this thing? 感觉好像看过这样的东西。有点像那个 tangent plane 那边附近的东西，对不对 ？tangent plane。Okay, but 这个是什么东西哈 ？Actually, this is really the derivative of f when applied to RT with respect to t. What I use here, this is chain rule. Okay, this is chain rule. 看到 chain rule because there are 3 directions, then you respect every direction is respect to t. 还记得吗？那个 3 那个 3 对没有错。So you are integrate over a derivative. This is one variable already. So you can use FTC. So here we can use FTC here. This one is for one variable FTC. For calculus 1. So what do we get here? We just take the difference with the endpoint. Okay, so I mean to be related to what you learned before is this. So what I want to say is a fundamental theorem for line integral, we really derive it from calculus 1 and FTC. Together with chain rule, that's all. Actually, it's from what you have learned. 所以这个好处是什么 ？In FTC of one variable 那个线是直的 in 2D, but now our line can be curved in 3D， 也是头剪尾就好，是不是很开心？没有 extra 东西好算，就是也是头跟尾剪这样，也可以得到， which is very good. Actually, this proof can generalize, right? Can generalize to n dimensional. 其实就是多加几个这个 variable 在上面。对，很好。去到高的 higher dimensional 还是头跟尾剪一下就好。Okay. Yeah. Any question? Thank you, ma'am. Okay, if no question, if you still have update for your presentation, please update me. And at the same time, you should write down your project tool. And after presentation, maybe based on suggestion from me or the audience, then you do some adjustment on your project tool. And then we will set a deadline for project 2 as well. Okay, then we will set a deadline for project 2 and actually correction for project 1. Okay, both deadline. And then we will finish the course. We'll finish the course. Yeah. Okay. Yeah. Oh, right. Okay. So about this beamer slide, 其实你要给我 draft 也可以 ，build 也可以 ，but I think so 我们是拜3哈，我们拜2，我给我想一下。I think on Tuesday 5 o'clock, before it, you have to give me a complete version. Okay, so on that day, you will use my laptop to present. So I will keep everyone in a share folder. So I will give you a link. You just upload there.
Okay, yeah, you just upload to the share folder, and then on that day, you will use my laptop to open your Beamer PDF present. Yeah. So Tuesday before 5 o'clock, upload your complete version that you want to present. Okay, I'll give you the share link later. 慢一点给，不要太早给，因为等下你又改上改下改上改下，又要进出。You cannot delete once you upload，只有我可以 delete 吧？对，就是一个完整的，你最后给我就对了。OK， OK， is it clear? Clear? Yeah, yeah. Graph 没有这样重要啊，因为我容错率很高，我是要看你怎样对付你自己的错误。But 到 project 的时候，应该我改完你的 project one，你就大概知道我要什么东西，你大概知道什么不要写，什么该写，应该差不多就是这样。Yeah. I guess project one maybe 没有project two 应该没有 correction 啊，因为应该来不及改，我只会给你机会改你的 project one 吧。然后如果你有 do correction，maybe I can give you extra mark up to 2 marks 也是哦，但是不会超过10分啊 ，obviously。OK 吗 ？Yeah. So I guess correction for project one 跟 project two 会是同一个时间交，我的 plan 是这样。And then 你交 project two 的时候，你的 Beamer 也是要 attach 进去，所以到时候你还是可以改你的 Beamer 如果需要。OK，Yeah， 其实错不用紧啊，如果你那天讲错啊或者写错啊不用紧，但是我要看你怎样去对付你自己的错误，怎样去改它或者怎样去 explain。OK 吗？不可能有一个180的 presentation， 不可能的，这是 impossible。Yeah. 所以你会看到那种很 presentation 很好啊 ，online 啊 YouTube 啊那种人啊，其实他们的 presentation 是 spontaneous， 他没有来，他可能有想一点啊，大概要讲什么，但是讲出来每一个字啊都是 spontaneous， 不可能 plan 好了，写好一个 script 出来的，不可能的。那种东西 present 出来是没有人听的，我老实跟你讲，明白吗？ Yeah， Yeah。那种写 script 啊，好照着念啊，是没有人听的，听不懂啊，人家也听不进去的。你要人家听得进去的是你当下可以说服你自己的，你才可以说服人家。所以人家要跟着你那一套逻辑走，你就会说服人家。好的演讲都是这样出来的。所以意思说什么？其实他每一次讲啊，都有可能都有小差别，都不太一样。可能他的 main point 是一样，但是讲出来的东西都不太一样。每一个字眼啊 ，the usage of word 啊，还是什么时候用到这个 word 啊，都不一样的。如果你认真去看那些好的演讲的，OK 吗 ？Yeah，OK。所以最重要是你要说服你自己，你才可以说服我，才可以说服观众。OK，Yeah，OK 啊，还有问题吗？有问题吗？有问题吗？知道要做什么了？OK，so we'll see you on the next Wednesday.